This is GMAT 41. You are welcome to this basic channel of excellence. If this is your first time of coming across the GMAT 41 basic class channel, GMAT 41 basic class, please right away smash the subscription icon. Go ahead and turn on your notification bell so that whenever I upload any content or come on live on this GMAT 41 basic channel, you will be personally notified. In this short video lesson, I would like us to give attention to this expression on the board. It is an integral expression, integration, okay? And of course, this expression on the board is based on standard integral. Standard integral happens to be one of the most important things that is students learning integral calculus is expected to be well familiar with. Standard integral. So here I would like us to just give attention to this particular function. Whenever you are given something like this to integrate, what will be your result? Now there is a standard result that this is going to give to us. And that is simply what I want my dear friends to learn from this video lesson. So we are given integral of k all over a squared plus f of x squared. We are to integrate this expression with respect to x. Okay, so integrate k over a squared plus square f of x dx. And that dx means with respect to x. What is the standard of this type of expression whenever you meet it, so that if you are solving a problem that is of this kind, you can easily smile and smash that problem? Come along with me. Let us see what the standard solution of this integral is going to be. But first, I would like you to understand this expression. This is integral of a constant divided by another constant plus a variable square. Now, I want to take note of something here. That the numerator is a constant, okay? A number. A number. If you come to the denominator, you have sum of two squares. That is addition of two squares. Addition of two terms, each of them is a perfect square. Okay? But again, I'd like you to take a look at something here. This a square, no argument, it is a perfect square. But I would like you to know something here, that it is best, yes, as GMAT 41 wants you to know, it is best that you refer to this also as a constant. Yeah, we know it is a perfect square here. But the truth is, if problems are given to you, it is possible that this number here won't be given to you as a perfect square. So just understand this expression here to be integral of a constant divided by another constant number, all right? Plus square of a variable, square of a function. So this is a number, and this is a function of something. Like in this case, it's a function of x. This is how you try to identify this type of function that I want to deal with, and have your friends learn what the standard integral is going to be. And this is the standard integral solution to this expression. Quickly, I'd like you to take your mind back to differentiation, because there's something about integration. Integration reverses differentiation for you. Under differentiation, there was this function we differentiated, and we got something that looked like this. You can learn more about that function by clicking this info link. It will take you to a unique video where you will learn your standard derivative for every other function. So that function is a secular inverse function. If you differentiate it, the answer you are going to get will look like this. That function is called tan inverse. Tan inverse of a given function. In fact, under differentiation, we saw it like this. Tan inverse of a function of x. Okay, usually I like dividing it by a constant number. So since we know that under differentiation, if you differentiate a function called tan inverse of a function divided by a, okay, divided by a constant, your result will be something like this. Therefore, if you integrate this expression, you're going to get back this function which you differentiated to get that expression like that. Therefore, my dear friends, in summary of everything I've said here, the standard integral solution of a function that looks like this is equal to, this is the result, the constant in the numerator divided by the square root of this constant number in the denominator, which in this case is a square, and then times tan inverse multiplied by tan inverse of square root of this variable, as you have there, that's square root of f of x raised to the power of 2 as given there, square root of this function here, and then divided by square root of this same number that you have here, this constant a squared. This is the solution. So if you integrate an expression like this, this is the answer you expect to get. This is the standard integral. And you know that once you are done integrating any function, you add your constant of integration. Because this integration is infinite integral. It does not have limits. No limit here, lower or upper limit. There's nothing like that. So after integrating, you add your constant. I'm using C to be the constant of integration. Now you see clearly that integrating an expression like this, the answer you would get, which is a tan inverse function, is this expression. Now one can break this down. Let me just write all k divided by, now you know square root of this a square. This square root, we cancel this square. So this is simply over a, and then tan inverse of, if you come here, square root of this expression that has square. The square root, we cancel this square, which simply means you are picking this function of x alone. Tan inverse of f of x, and then all over the same thing, you have a here plus c. I hope you've learned something. This is the standard integral value, standard integral solution. So integral of an expression of this kind. And remember how I interpreted this expression. A constant divided by another constant plus square of a function or a variable. Right? Yeah. Let us see one question here. Let's take a question, okay? And see how we apply this standard that I've just shown you. As an example, e.g., if I give you this expression to integrate, say 5 divided by, let's say 2 plus x squared dx. What will be my answer? Now, without wasting time, take a look at this expression we are asked to integrate. You notice it is a constant divided by another constant plus square of a variable, square of a function. So it follows this expression, this standard. And hence, we can simply do our copy and paste to get our answer, because whenever you're given integral of a function like this, this is the solution like I said. It's just for you to do your copy and paste. Let's get to the answer of this. The integral of this function is simply 5 divided by, remember you must take square root of the constant term in the denominator. Constant in the numerator, look at it, divided by square root of the constant in the denominator, square root of what? 2. And then next, tan inverse of square root of this whole function of x. And square root of this x square, the square root will cancel that square, so you'll be left with x. Divided by this same denominator here. That is square root of 2. Once you do that, you put your plus c. And this, of course, is our answer. Very simple, isn't it? Remember, this is the GMAT 41 basic class channel. Here we break down basic concepts so that you friends can get your foundational knowledge strengthened to face other higher concepts. All right, how about we take a look at this other example? Let this be example 1. Okay, let's look at this example 2. What if I ask you to get me the value of y, solve this equation, that y is equal to integral, let us say, now you have to integrate this with respect to x. What will be your answer? Simply, therefore, y is equal to, now if you look at this expression given to us to integrate, you'll agree with me that it follows this pattern. The numerator is a constant. The denominator here, you have a constant plus a function here raised to power 2, a variable raised to power 2. You notice that here contains an alphabet. That's what we call it, a function or a variable. So just do your copy and paste. This is the standard. It's just like somebody telling you if you integrate cos, you will get sine as your answer. Or if you integrate square sec of a function, you would get tan. So if you integrate something like this, just like I showed you here, you'll be getting a tan inverse function solution. So for this, let us do the copy and paste and see. First, the constant in the numerator divided by square root of this 25. That is square root of this constant in the denominator. So this is going to be over 5. You know, if I want to rewrite this in a way before solving, this question given here is still the same as integral 3 all over 5 square. So that you see this square term like I gave it in the, expression that I used in giving you the standard. The denominator is a sum of 2 squares, addition of 2 squares. I could actually also have converted these 2 to perfect square if I want. If I want to convert these 2 to perfect square, it's going to be, first, I will introduce square roots to that 2, and then I will square it. With this, I've converted this 2 to a perfect square. You notice I have not changed this 2. This square root can still cancel this square. And it will leave us with this 2, telling us that I have not changed anything there. Okay, so that denominator is actually a sum of 2 squares, by the way. Okay, but your examiner giving you a question may decide not to give you this one as a perfect square. It still doesn't matter. Always remember that once you pick the numerator, you write it out, it's going to be divided by square root of any constant number you have in the denominator. Then tan inverse of square root of this whole function here. Of course, the square root will remove this square. So you'll be left with what? X minus 7. Divide this by square root of this same constant in the denominator. Square root of 25 will give you 5. Then plus your constant of integration. This is our solution. And I hope my dear friends have learned something wonderful from this video lesson. Like and subscribe to this channel if you are yet to do so. Leave your comment and share this video to your friends. Okay, encourage them to visit this GMAT 41 basic class channel. And then subscribe as well too. Remember to follow GMAT 41 on the GMAT 41 channel as well too. Channel specially dedicated to our dear scholars in higher grades, grade 10, 11, 12, and advanced level university as well too. This is the link to that channel. You can click on it and then, of course, subscribe. You have a lot to learn from there. Complete lesson on integration and on calculus generally is there on that channel. I'll see you in my next video.